Okay, solid state. Solid state refers to one of the fundamental states of matter in which particles, atoms, ions, or molecules are closely packed together in fixed position. Solids have definite shape and volume, unlike liquids and gases. Strong intermolecular forces that hold particles tightly, very limited particle movement, only vibrations about fixed points, high density and incompressibility compared to gases and liquids. In physics and chemistry, solid state, the branch of science dealing with the structure and properties of solid like crystals, semiconductors, and metals, or crystalline solids, a pure, homogeneous, solid substance which is composed of atoms, ions, or molecules are arranged in a definite pattern with fixed geometric shape having sharp melting point is called crystals. When minute crystals are packed together in a well-defined order, then crystalline solid are formed. So solid with geometric shape is called crystalline solid. Properties of crystalline solids. Crystalline solids have definite shape. Crystalline solids have long range order due to regularity, repetition of constant particles in 3 dimensions. For example, sodium chloride crystals in composed of sodium ion and chloride ions, where such ions is surrounded by 6 another ions in 3 dimensional structure. Crystalline solids are anisotropic, that is, their physical properties such as refractive index, electrical resistance have different values along the different directions within the same crystalline to different arrangement of constant particles of crystals along the different directions, although these are repeated in a particular order. Crystalline solids have sharp melting point due to arrangement dismantle disorder by heating which is sufficient to disturb in the long range order of crystalline arrangement. Amorphous solids, the substances in which the constituent particles are arranged randomly with short range order, are called amorphous substances. Properties of amorphous solids. Amorphous substance are not true solid. It is short range order, that is regular and periodic repeating pattern is observed only for short distance. Amorphous solids are isotropic, that is physical properties such as refractive index, electrical conductivity, these are found to be same in all directions due to arrangement of constant particles in irregular along all directions. Amorphous substances do not have sharp melting point. When such substances are heated, the vibration and mobility of atoms takes place. But nature of arrangement of atoms does not change. When amorphous substances are caught with sharp edge tool, then they break into two pieces with irregular surfaces. Difference between crystalline and amorphous solid. Arrangement of particles. The constant atoms, ions, or molecules are arranged in a definite geometric pattern of particles in crystalline solids, whereas in amorphous, there is no definite geometric pattern of constant atoms, ions, etc. In case of melting point, crystalline solids melt sharply at their melting point, whereas amorphous solid melts gradually over a range of temperature. Regular and irregular cuts. A crystalline solid on being cut with sharp edge knife gives a clear cleavage, whereas amorphous solids breaks irregularly. Isotropy and anisotropy. Crystalline solids are anisotropic, that is, their physical properties such as refractive index, thermal conductivity, electrical conductivity are different in different directions. But amorphous solids are isotropic, that is, their physical properties are same in same direction. Classification of solid substances. Crystalline solid, a pure homogeneous solid substance which is composed atoms, ions, or molecules are arranged in a definite pattern with fixed geometric shape having sharp melting point is called crystals. When minute crystals are packed together in a well-defined order, then crystalline solid are formed. So, with geometric shape is called crystalline solid. Properties of crystalline solid. Crystalline solids have definite shape. Crystalline solids have long range order due to repetition of constant particles in 3 dimensions. For example, sodium chloride crystal is composed of sodium ion and chloride ions, whereas such ions is surrounded by 6 another ions in 3-dimensional structure. Crystalline solids are anisotropic, that is, their physical properties such as refractive index, thermal conductivity, electrical resistance have different values along the different directions within the same crystal due to different arrangement of constant particles of crystals along the different directions, although these are repeated in a particular order. Crystalline solids have sharp melting point due to arrangement is dismantled, that is the disorder, by heating, which is sufficient to disturb in the long range order of crystalline arrangement. Amorphous solids, the substance in which the constant particles are arranged randomly with short range order are called amorphous substance. Properties of amorphous solid. Amorphous substances are not too solid. It is short range order, that is regular and periodic repeating pattern is observed only for short distance. Amorphous solids are isotropic, that is physical properties such as refractive index, electrical conductivity, thermal conductivity. It is are found to be the same in all directions due to arrangement of constant particles is irregular along the all directions. Amorphous substances do not have sharp melting point. When such substances are heated, the vibrations and mobility of atoms takes place. But nature of arrangement of atoms does not change. When amorphous substances are caught with sharp edge tool, they break into two species with irregular surfaces. Difference between crystalline and amorphous solid arrangement particles, the constant atoms, ions, or molecules are arranged in a definite geometric pattern of particles in crystalline solid, whereas In amorphous, there is no definite geometric pattern of constant atoms or ions. Melting point. Crystalline solids melt salt at their melting point, whereas amorphous solids melt gradually over a range of temperatures. Regular and irregular cuts. A crystalline solid on being cut with sharp edge knife gives a clear cleavage, whereas an amorphous solid breaks irregularly. Isotropy and anisotropy. Crystalline solids are anisotropic, that is, their physical properties, such as refractive index, thermal conductivity, electrical conductivity, etc., are different in different directions, but the amorphous solids are isotropic, that is, their physical properties are same in same direction. Ionic solid crystal. In this solid, the constant particles occupying the lattice points are the oppositely charged ions, that is, positive and negative ions. These ions are held together by the strong electrostatic force of attraction. Characteristic of ionic solids, they have high melting point and boiling points due to strong electrostatic force of attractions among the ions. They are good conductor in the molten state and in the aqueous solution. They are soluble in polar solvent but insoluble in non-polar solvent. The ions are closely packed and hence the ionic solids are hard in nature. For example, sodium chloride, potassium chloride, calcium chloride, etc. Molecular solid, the constant solid particles occupying the lattice point in this case are the molecules. The intermolecular force holding the molecules together in the crystal lattice are the weak van der Waals force of attraction. Characteristics of molecular solids are the van der Waals force are much weaker than its electrostatic force existing in the ionic crystal. The molecular solids are soft and have low melting point and boiling point than ionic solids. They do not conduct electricity in the solid or in the liquid state. They are less soluble in water and more soluble in non-polar solvent. They are volatile and have low heat of vaporization. For example, hydrochloric acid, ammonia, water. Covalent solid. In these crystals, the lattice points are occupied by the atoms which are linked together by a network of covalent bonds to form a giant molecule. A common example of the covalent crystals are diamond, graphite, etc. Characteristic of covalent solids. Most of the covalent solids are bad conductor of electricity except graphite. But graphite is good conductor due to mobile electrons. They are insoluble in polar solvent but soluble in organic solvents. The covalent solids are insoluble in polar solvents like water but soluble in organic solvents in like benzene, alcohol, ether. Such type of solids always high melting and boiling points. Metallic solids, an electrostatic force which bind the various metal atom together is called metallic bond, and it is good conductor of electricity in the solid state, but ionic and covalent solids are bad conductor of electricity, which shows that nature of bonding among the metal atom must be different than ionic or covalent solids. Characteristics of metallic solids, metallic luster. When light falls on the surface of metal, the free electrons absorb the photon of light and are set into vibration. The vibrating electrons emits energy and becomes a source of light. Thus, incident light appears to be reflected from the surface of the metal, which is responsible to show metallic luster. Electrical conductivity and thermal conductivity. Metallic solid shows the property of electrical and thermal conductivity. Metallic solid shows the property of malleability and ductility. hardness of metal. This property may also be explained on the basis of strength of metallic bonds.